Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to look at a specific example just so we can practice using Cramer's rule to solve the matrix equation. So this is a 5.3 in our textbook by Gilbert Strang. Cramer's rule example. So imagine we have the equation, maybe the matrix equation of 2, 3, 4, 5 times the vector x. It's like x1 and x2, and maybe it equals something like 0 and 2, 0, 2. There. How about that? So we're going to solve using, so let's make a note of this. Let's solve this. Solve using Cramer's rule. So here's how the problem sets up. Remember what we said is really what we have to first solve. We're going to solve the problem A x1 equals the matrix B1, and then we're also going to solve A x2 is equal to the matrix of B2. So let's write this first one out. The first one would say the matrix A is 2, 3, 4, 5. The matrix of x1 says you put the vector x in the first column, so x1, x2, and then you put the identity column in the second column. So in the second column, you put the second column of the identity with E2, or specifically 0, 1. And this is then equal to the matrix B1. Well, B1, it says the first column is B1. Oh, I'm sorry. We actually have what B is. B is 0, 2. And then in the second column, we put the second column of A. That's 3, 5. Now, in order to solve this is a few things. First off, we said that the determinant of x1 is very simply the first component of the vector x. So the hard work here is we have to find out what the determinant of A is. Well, that's going to be, looks like a 10 minus 12, so that's a negative 2. And then we also have to find out what the determinant of B1 is, and that looks like it's going to be a 0 minus 6, so minus 6. And there we have it. Our first vector is x1, which equals the determinant of B1 divided by the determinant of A. Well, that's going to be minus 6 divided by minus 2. That's just 3. And maybe I did that a little fast, so we'll just do the review again. Notice that now Cramer's rule, x2 and b2 are square matrices. And so the big step was to apply the determinant to both sides. So A times x2, the determinant of ax2 equal the determinant of b2. And we said that the determinant of the left side becomes the determinant of A times the determinant of x2 that equals the determinant of b2. And just to show you that this is going to work, let's try the determinant of x2. Well, that is going to be the determinant of x1. Oops. So x2, well, what does x2 look like? x2 now means that the identity is in the first column and the x vector is in the second column. Oh, but look at that. That's a diagonal matrix. So that's the product of the diagonal components. That's 1 times x2. That's just x2. And so now our equation becomes the determinant of A times x2, the component of x, equals the determinant of B 2. Well, we know the determinant of A, or so let's write it this way. So x2 is the determinant of B2 divided by the determinant of A. And that we already know. The only thing holding us back right now is defining the determinant of B2. Well, the determinant of B2 says, it says that you put B in the second column. So that is the 0, 2 goes in the second column. And the first column of B2 is the first column of A. That's 2, 4. So let's see. If we take this determinant, it looks like we have a 4 minus a 0. That's 4. And now we can put these in. So B2, so this is going to be a 4, divided by the determinant of A. Well, we found that earlier to be minus 2. So x2 is minus 2. And there it is. X, the solution, is x1, which we said is, where did it go? Oh, up there at the top is 3. And x2 is minus 2. And we're done. Now, I'm pretty comfortable with that answer. But you should always check. If it's possible, how could you check your work? Plug x into this original equation and see if it works. So let's do that before we before we make our peace with this problem. Let's check. So if we take 2, 3, 4, 5, and we multiply this by the vector 3 minus 2, this is going to be a 2 times 3 minus 3 times 2 minus 6. And then this row 2, column 1 is going to be a 12 minus 10. Oh, and look at that. There it is. That is 0, 2. And it worked as suspected. And that is how you actually use Cramer's rule. I hope that helps. And thanks for watching.